Okay, so now we have the sine rule, or in pre-cal or in Algebra 2 you called this the law of sine. So oblique triangles are triangles that have no right angles. So that means you can't use the Pythagorean theorem because you don't have a hypotenuse, and you can't use the standard sine, cosine, tangent because you don't have a hypotenuse. Now, tangent doesn't use hypotenuse, of course, but it uses opposite and adjacent. And if you don't have a hypotenuse, you have more than one adjacent side. So you don't know which one to use there. So those are out. Now, first of all, when you draw a triangle, if they're giving you letters, standard notation, capital letters are angles. And it really doesn't matter where you put each letter unless they tell you specifically that one of them is a right angle. I just kind of like going in order like this. Little letters are across from their big letters, and little letters are always sides. So notice B is across from B, A from A, and C from C, and so on there. So also remember that all angles in a triangle add to 180. Sometimes you don't have the information that you need, but you can subtract from 180 to find the information that you do need. Okay, so to use law of sine, and basically you need to have one complete pair. You need to have a side and the angle across from it, and then either one other side or one other angle. And then you can find your other things from there. Now, I'm using notation like you did with congruent triangles. We're only dealing with one triangle, but it goes over the placement that you would of those angles. So, for example, I could have angle, side. Notice that this side and angle are across from each other. That would be my complete pair. And then I have an angle here that I could find the side across from it. Angle, side, angle, side, angle. Okay, this one is a little tricky because it doesn't, I don't have the angle across from that side, but if I know these two angles, of course, I can subtract from 180 to find that one. And now I have a complete pair. Side, angle. Okay, so here's my complete pair. I'd be finding this angle right here. This one has an asterisk next to it and actually says see last example. I'm not sure that it's actually our last example anymore. But what that's getting at here is in pre-cal and possibly in Algebra 2, you talked about this thing called ambiguous case, that sometimes the angle that you would find whenever you have this scenario, there is more than one possibility. We don't have to cover that in here, so we're not going to. If it's something you want to know more about, let me know and I can talk to you about it. It's actually not in your book. Most students, I don't think, are going to care that we're not doing it because it's something that's kind of confusing about when do I have to do it, blah, blah, blah. So just realize that we will only have one possible answer for everything that we're going to do. Now, the actual law of sine, I really should have mentioned that before I went through all the triangles. Notice that you have three fractions here for your three different sides and angles. You're only going to be using two of these at a time. So again, you'll know one of these completely, and then you'll know half of one of the other ones. Now, this is the way that the formula is presented in your formula booklet. But sometimes you do see this ratio upside down where you have the signs on top and the sides on the bottom. It doesn't matter. You can do it either way. Just be consistent. You can't decide that you're going to put this angle on the bottom, but then put angle B on the top. Okay, so if a question says to solve the triangle, that means they want you to find everything that you don't already know. Now this says that we're going to round answers to the nearest tenth, but actually we're going to do 3 sig figs. Okay, so A, B, C, I just kind of like labeling mine like that. And you can draw your triangle however you want to. I know this triangle looks like it's a right triangle. That's just because that's what I had to choose from in Word. So it's not a right triangle, okay? This we're going to say is 33. This we're going to say is 46. Little letter B is 4. Now, you don't have to draw a picture. Law of sine is pretty easy to set up. Like I said, you have that complete pair right there. So this is going to be 4 over the sine of 33. Now, since I know the 46, that's the first thing I'm going to find right there would be little letter C. So C over the sine of 46. Now, to solve this, we did something like this the other day. I'm going to cross multiply. So 4 sine of 46 is equal to C sine of 33. I always put my sides in front of my sine of an angle. That way it doesn't look like I'm, doing, for example, over here, 464 degrees. I know that it's just a 46. I'm going to divide here to get the C by itself. So 4 sine of 46 over the sine of 33. Now, I'm going to put these angles in a parenthesis here, and here's why. When I go to put this into the calculator, we've got 4 sine of 46. I don't want to immediately hit divide by here. If I do, whatever I put after this is only going to divide the 46, but I want it to divide all of this. So either close that 46, then you can do divide by sine of 33. Okay, you can see the answer there. Or do 4 sine of 46, hit enter. That's the top. Divide by the bottom. Either way, notice I end up with that same answer, 5.28 if we do 3 sig figs there. One thing that students do with this is they kind of get the setup right, but then they end up getting the answer wrong because they don't know how to put it in the calculator. And that's kind of a silly reason why to get it wrong there. Okay, so I've got C. Now we can, in order to find little letter A, I need to know the angle across from A. I can go ahead and find that now. I actually could have found that from the beginning. 180 minus 33 minus 46. That's going to give me 101 degrees. I'm going to label that over here in red, so I know that we didn't start off with that. Now, when I do my ratio here to find little letter A, use the 33 and the 4 again because those were exact values. C was rounded. I could use it if I needed to, but I don't need to. I can use B again. It's not like a word bank or something where once you've used it, you can't use it again. So 4 sine of 33 is going to be A over the sine of 101. Make sure that you have your angle there with the sine and not having it mixed up and on the top there. And also make sure that you actually put the sine in the law of sine. I've seen people do this before where they just put 4 over 33. Obviously, that's not going to give you the same answer. So A sine of 33 is equal to 4 sine of 101. I don't need to see all of these steps either. Once you kind of get the hang of this, if you feel like you can just do these last 2 steps in the calculator, that's fine. But I do need to see that setup right there. Okay, we end up with A is approximately 7.21. Okay. All right. The next one, we're just going to find little letter C just because I want to force you to start there and show you something that we haven't done yet. So in this case, A, B, C, 80, 77. Again, this is not drawn to scale. Little letter A is 15. Okay, I want you to find little letter C next. Okay, well, problem, to find little letter C, I would need to know angle C, and I don't know angle C. But I know angle A and B. Okay, so again, that's one that sometimes students kind of are at a loss, and they think they can't do it, and they forget, hey, I know that the angles in a triangle add up to 180. So this is 23 degrees. Now I have that complete pair, and I have the angle across from that side that I want to find. So 15 over the sine of 77 is equal to C over the sine of 23. So this is going to solve the same way the other ones did here. Again, I'm just going to kind of skip at this point, but you're going to cross multiply and solve. I end up with that C is approximately 6.02. Don't shortcut if you can't. You know, if you need to actually show the step where you cross multiply and where you divide, by all means do that. Okay. One more of these, and then we've got a story problem here. So ABC, B is 30.6, B is 7.42, C is 4.54. Okay, so in this case, I'm going to be starting off finding angle C because here's my complete pair, and this is another half of a pair that corresponds to C. Now, these are all decimals, but, you know, as far as I know, these are all exact decimals, and it doesn't really matter because that's all I've got. So 7.42 over the sine of 30.6 is going to be 4.54 over the sine of C. Okay, so 4.54 sine of 30.6 is 7.42 sine of C. Divide to get the sine of C by itself. This one's going to be a little bit different than the other ones we've done. Okay, so I'm going to end up doing an inverse of this number right here. So I'm going to put that in my calculator. I'm going to get an answer, and I'm going to take the inverse sine of that answer. Now, this answer right here is approximately 0.311. Okay, but don't round that off. Okay, use that exact answer that's in your calculator. Do the inverse sine of answer. And I end up with that C is approximately 18.1. Okay, just in case we need to see that, let me show you how that would look in the calculator here again. So 4.54 times the sine of 30.6. Now remember, either close that parenthesis before you do the divided by or hit enter. I actually did both there. Didn't really mean to do that, but 7.42. So there's the number that I wrote down but said, hey, don't really round that. Okay, I want to do an inverse sine of that answer. So again, hit second and the negative key to get that answer to pop up there. If you type in all those decimals, that is not going to be the same. The calculator stores more decimal places than it shows you. Okay, so we get that, and again, to 3 sig figs, that's my 18.1. If you're not comfortable using the answer key, again, you can store it as C, because that's really what I saw for. Doesn't matter if it's a capital or a lowercase, either way there. All right, so we're not done. Let's finish this one out here. Okay, so now I know C. Let me throw that in here, 18.1. Now to find A, I know nothing of A, but I can find angle A by subtracting. So A is going to be 180 minus 30.6 minus 18.1. So A is 131.3. I don't have to see this step, but it's nice to show. I can give you partial credit even if you subtract it wrong. If you don't want to write out all the decimals here, you could always just write minus B minus C. That would be acceptable too. Now, once I know that now I can find my missing letter A. So again, stick with the B. Even though B was decimals, again, for all I know, that could be exact decimals. So plus, you've already set that one up. You hopefully already know that it's set up correctly. So why chance it and have an issue with maybe putting C set up incorrectly? Okay, so now when I work that one out, I'm not going to go through all the steps there, but we would cross multiply and then divide. I get that A is approximately 10.9507, so on and so forth. To 3 sig figs, that's going to make the 5 round up the 9, which makes the 9 round up the 0. So we end up with 11.0. That's one of those kind of weird rounding situations there. Now, it was a lot of work to find all this. If all they asked you to do was find angle C, only find that. So pay attention to the directions, only find what it is you absolutely have to find. Now, something that I had here as a disclaimer and forgot to mention, once I have the 5.5, well, from the very beginning, I had 2 sides, but I can't use the Pythagorean theorem to find letter A because it's not a right triangle. So again, that's only allowed when it's a right triangle. Don't assume that you have a right triangle. They will tell you, or they will give you some kind of indication. You've got a square, you have an altitude, something like that, perpendicular bisector, some kind of wording that makes you know that you've got a right angle there. Okay, so the last one here, we've got some kind of overlapping triangles. We're going to find the height of the mountain. So basically, I've got this car right here. The angle of elevation to the top of the mountain is 22. Another car that is 10 miles away, the angle of elevation to the top of the mountain for it is 10 degrees. and the angle between these two angles of elevation is 12 degrees. Now that's kind of a little weird that you would know that angle, but that's going to help us solve this question here. So really what I have now is I have two adjacent triangles, and totally when you have a question like this, redraw it without all that other stuff there, because it's a little hard to see the triangles with the mountain and the cars and all that kind of stuff. So here's what I have going on. I'm trying to find the height of the mountain. Well, in order to find the height of the mountain, I would need maybe two other sides to do the Pythagorean theorem, because the height is always at a right angle. If you remember, I told you that back in section 1 with some of that miscellaneous geometry stuff. Well, I don't know the two other sides here. Well, I have an angle here, but in order to use trig to find h, I would need to know one other side, which I don't know. So let's work on this triangle right here. If I can somehow find a, or this angle, this side down here, I could find h. Well, there's no way that any of this triangle is going to help me find this over here, but of course this triangle butts up to a. So I can find a in this triangle and then carry it over here. So that's what I'm going to do. So in my scenario over here, I need a complete pair. So my complete pair, I only have one side, and that's the 10 miles. The 10 miles is across from the 12. So I'm going to have 10 over the sine of 12. I'm looking for A. So A is across from angle 10. A over the sine of 10. Now, redraw that triangle if you need to. I don't know this angle right here, although I could find it, but that angle corresponds to B, and I don't know B. I don't care to know B. So that's information that I don't need. So we're going to cross multiply here and solve. I get that A is equal to approximately 8.35. Now, in this case, honestly, I used the 8.35. I didn't use an exact value, although I really probably should have. 8.35, we can see here in a minute how much of a difference that would make. 22 degrees and h. Now, to find h, this is a right triangle. So you could use law of sine with this 90 degrees here and so on, but honestly, I think right triangle trig is easier. So this is my opposite, and I know my hypotenuse. So this is a little bit weird because h here is actually my opposite side. The sine of 22 is equal to h over 8.35. So 8.35 sine of 22 is equal to h, and h is approximately 3.13 miles. So let's go back here just because I'm curious and see how this answer would change if I didn't round the 8.35. Let's see how much it would change here at the end. It may not change at all, but it might at the very same time here. So that would have been 10 sine of 10 divided by the sine of 12. That's how I got my letter A there. Okay, so now let's use that answer instead now. So I'm going to have the sine of 22 equals h over answer. So I'm going to take my answer times the sine of 22. So my answer times the sine of 22. And to 3 sig figs, it's the exact same thing. So it doesn't make a difference here, but just to be safe, I would carry that answer through there. Now, if it's a part A and a part B kind of question, then you may not need to worry about it. But just to be safe, I would carry it on through, or realize that if you don't, that your answer might be slightly different than what's in the book. Okay. So again, let me know what you've got questions about here. Several of these questions you're just doing part A because part B was exactly the same and I didn't see any reason for you to practice it twice. But feel free if you need some extra practice to do some of those part Bs, especially if you can tell that it's the same setup as the part A, especially if you had a hard time with that. Okay. Again, solutions are in Google Classroom as well as the PDF. The assignment is on my website.